Hi, hello everyone. This is your educator, your tutor, your friend Sanjay Kumar Vishwakarma. I welcome you all to yet another session of We Learning. We Learning is a platform which focuses on providing right to quality education for all. Do watch this session. If you like it, do press the like button, share it with your other friends who are preparing for their boards and competition as well. Subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. Alright? And do visit our website www.we-learning.in. All these sessions you'll be getting there. Along with that, you'll be getting lecture notes also which you can download. Okay, do check it out. Now without any delay, let's get started with today's session. This is current electricity and we have reached lecture number 9. This is going to be very important lecture because in this lecture we are going to talk about Kirchhoff's law. Very important law, right? One thing why this session is going to be important, because this is something which is very different. You have not studied it in your 10th standard. It is something which is new for you, right? And this particular thing, if you understand this law, you can solve every kind of complex questions very easily. Okay? Whether you know to find the equivalent resistance or not, still you can find this. You can find the current in the circuit, the potential drop across the resistors very easily if you just understand this law properly. So do take out your notebooks and pens fast and get ready for the class. All right. Now, what is Kirchhoff's law? Kirchhoff has given two laws. Kirchhoff's first law is, before telling about the law, in some books, it is written Kirchhoff's first law. In some, okay, one more thing. This is Kirchhoff, K-I-R. Many times we speak fast, so it is like Kirchhoff, right? K-R-I, but it's not K-R-I, it's K-I-R. Second thing is, it's C-double-H, not C-H-O-F-F, okay? It is Kirchhoff's law. So in some books you'll find it is written only Kirchhoff's first law. In some books it is written in NCERT, it is written junction rule. What is it written? Junction rule. Or in some books it is written Kirchhoff's circuital law, current law. Actually, it is Kirchhoff's circuital law. In short form, they call it KCL. KCL. So this term we'll use mostly. Okay. What this law says? This law says, it states that at a junction in an electrical circuit, the sum of current flowing into the junction is equal to the sum of current flowing out of the junction. See, these laws are very easy. There are only two laws, very easy laws, just understand them. Okay, and this one is something which you already know. It says it's at a junction. What is a junction? A junction is a point where three or more wires meet. All right, current direction can be any. Let's say it is something like this. So this particular thing is a junction. Okay, where three or more wires meet. Clear? Now, in this, the sum of current flowing into the junction is equal to the sum of current flowing out of the junction. Okay, like for example, let's say there are two wires. From this wire the current is going as 2 ampere. From this wire the current is going as 1 ampere. Now there is one more wire. How much current will be coming out from this wire? It's a common sense, 2 plus 1, 3 ampere, right? This is something which we already know. Now this is given by Kirchhoff. So this point is a junction. This point is a junction. Now if you see the sum of current entering, 2 plus 1, 3, right? And the sum of current exiting this junction is 3. Wait, this is 1. 2 plus 1, this is the sum of current entering and this is the sum of current exiting the junction. Right? So this is Kirchhoff's first law. Very easy, right? In some books it is written sigma I is equal to 0. What does this mean? What they tell when they write sigma I is equal to 0, what they say is take one direction of current, like if there is a junction, the current which is entering the junction, take it as positive, the current which is exiting the junction, take it as negative. Taking in that particular sign convention, the sigma I will come as 0. See here, 2, now this is entering, I will take plus 2. This 1 is also entering, I will take plus 1. This 3 is exiting, so I will take minus 3. Now just tell me the sum, 2 plus 1, 3 minus 3 is equal to 0. Clear? So this is also one way for getting this particular, for understanding this law. Okay? Sigma I is 0. Either you can understand this way or you can understand that way. Just if you are learning this, you just have to make sure, remember, current entering you have to take as positive, current exiting you have to take as negative. Clear? Okay, one more thing. What do you think, in which law this particular law is based on? This law is based on law of conservation of charge. Right? See, sum of current entering the junction is equal to sum of current exiting the junction. So at a junction basically, amount of charge entering per unit time is equal to amount of charge exiting per unit time. Correct? So in the same amount of time, if you see, the charge is conserved. The amount of charge entering is equal to the amount of charge exiting. So this is based on law of conservation of charge. Remember this, they ask in boards. They ask in boards. For this also they'll ask, for second law also they ask. Okay? Second law is based on some other conservation, we'll see. Note it down. Done? Alright. Now, let us understand from a question. Now here, find I. Where is I? This is I. We have to find the value of this I. The current is going like this, 4 ampere. This is going like this, 5 ampere. This is going like this, 10 ampere. How much current do you think will come out from here? See, from common sense, what I can understand is, this is 4, this is 5. And here it is going 10. How is this possible? 5 plus 4 is 9, right? 1 ampere should come from here also. Then only here it will be 10. See, from here 5 is coming, from here 4 is coming, from here if 1 comes, 5 plus 4 plus 1, 10. Then only 10 will go in this wire, right? If from all these the current is entering and here it is exiting, the current should be here 1 ampere. But now, let's say this was easy. So by looking at the question, I understood. Now, from using the law, how to find it? See here, the direction of current is mentioned like this. That means this is entering the junction, this is the junction. These two currents are entering the junction, these two currents are exiting the junction. Now we need to find I. Okay, see here. The answer what you will get will actually tell you the direction also. If it is coming positive, that means the direction which was assumed was positive. If I comes as negative, that means the direction which we have assumed, the actual direction is opposite to it. Alright, let's see. So at this particular junction, at O, let's say, current entering should be equal to current exiting. That means entering is 4 plus 5, exiting is 10 plus I, right? From here 9 is equal to 10 plus I, and from here I is equal to minus 1. What does this mean? This means that the direction of I, what we have assumed was wrong. The actual direction is in this side 1 ampere. Clear? Note it down. So if you want, you can note this point also. If current comes as negative, if current comes as negative, that means the current is in opposite of the direction assumed. Clear? Note down. The current is in opposite, or the current is opposite to the direction assumed, let's say. Clear? All right. Let's go to the next law. Kirchhoff's law, Kirchhoff's second law. So Kirchhoff's second law also has different names. One name is loop rule. Loop rule. Fine. Another name you will find mostly Kirchhoff's voltage law. In short, KVL. Okay. So usually you will hear more KCL and KVL. Okay. What does this law say is, it states that the algebraic sum of all the potential differences around a closed loop, underline this, in any circuit must be equal to 0. Note it down and underline these two things. It states that the algebraic sum of all the potential differences around a closed loop in any circuit must be equal to 0. Let's say there is a circuit. Now this circuit, in this complete loop, the sum of potential differences will be 0. This will be having some voltage, this will be having some potential drop, let's say delta V1 or let's say V1. This will be having some V2. The sum of all the three should be 0. Sigma delta V is equal to 0 in any closed loop, or let me just write closed loop. Fine. There sigma I is equal to 0 at junction. Here sigma delta V is equal to 0 in a closed loop. All right. So if delta V is 0, if the sum of delta V is 0, that means some voltages will be positive, some will be negative. It's very simple. If there is a voltage gain means we'll take V as positive. Okay. Voltage drop means negative. Fine. Voltage gain means positive, voltage drop means negative. How we will know whether there is a voltage gain or a voltage drop? I'll tell you. First, note this down. Very easy law it is. We just need to understand it. Now, let's learn how to apply it. Okay. Achha, before that, again, on which law this particular law is based on? Just see. See here, understand. In a closed loop, sigma delta V is 0. Okay. And it is but obvious if there is, let's say there is a point. Let's say this point is P. If I'm moving and coming back to the same point, if I ask you Vp minus Vp, what is it? 0 only, right? So in a closed loop, sigma delta V will be 0. Now from here you can understand in which law it is based on, what is conserved here. If you remember when I explained about potential, the very first thing was potential does not depend on path, it depends on position. That's the reason in a loop it is 0. From here to here, if I'm coming back, however I come back like this also. If I'm coming back to the same point, sigma delta V is 0, right? So this particular law or voltage first of all depends on position, not on the path, right? So if we are coming back to the same position, what is conserved? Energy. Kirchhoff's second law is based on conservation of energy, right? Potential difference is nothing but work done per unit charge, right? Work done by conservative forces per unit charge. So work done is conserved since we are coming back to the same point. Energy is conserved. Clear? Note down. In boards they ask KCl, it is based on conservation of charge. KVL, it is based on conservation of energy. Let's go further. Now the laws are done. Let us see how to apply KCL and KVL in a circuit. So whenever there is a circuit, the first thing what you will do is you will apply KCL. Then only you will apply KVL. Okay. From KCL what we will do? We will fix the direction of current first. Okay. The very first thing, follow KCL for distribution of current. Draw current from one or more cell. There will be different batteries in your circuit. It can be one cell, it can be two cell, it can be any cells, any number of cells. Draw current from one or more cell and distribute it in the circuit. The first thing, you have to distribute the current. Alright. Second, choose a closed loop. After you have distributed the current, we will choose a closed loop. Don't worry. For now, just write these points down. Once we'll do the question, it will become easy for you to understand. Okay. Now, choose a direction of closed loop. Any direction you can choose. There are two directions, either clockwise or anti-clockwise. Any direction you can choose, you will get the correct answer. Next, add the potential differences with sign. So now here, we'll be applying KVL. If the direction of path is from higher potential to lower potential, if the direction of path is from higher potential to lower potential, delta V will be negative. Clear? From higher to lower we are going. So the change in potential, basically potential drop happened, right? It will be negative. If the direction of path is from lower to higher, potential gain is happening. So this will be positive. Alright. Note it down. I will tell you. Let's see. Suppose this is a cell. Okay. Now, let's say first our path was this. This will be a closed circuit, then you will assume a closed loop. Suppose this is the clockwise loop, what you have assumed. So here for this particular thing, your path will be like this only, right? Okay. So now, suppose your path is like this. What will be delta V? If the EMF of the battery is E, what will be delta V? Here, potential drop is happening or gain is happening. This is at higher potential, this is at lower potential. We are moving from lower potential to higher potential. Potential gain, right? This will be plus E. Plus E. Now, there is one more cell. Again, the same. Everything is same. This is E only. This is plus minus. This time I have just changed the path. Now suppose my path is like this. Okay, here the path was like this, there the path is that way. Let's say it was a anti-clockwise thing, so here it came like this. Now, what will be delta V? See here, from higher to lower it is going. Potential drop minus E. Clear? Now, next. See, there is a way also to remember it. See here. From negative to positive you are going. Where you are going, use that sign. Wherever you are going to, use that sign. Not from, to. It is from minus, but you are going to positive. So if you are going to positive, it will be plus E. See here, you are going to negative. The direction is this, to negative. So it is minus E. Clear? Now, for resistors, see here, let's say the current is flowing like this, or in the first one we'll take current like this only. Okay, this is the resistor R, current flowing is I. Now if my path is like this, what will be delta V? Positive or negative? Current is flowing like this. Current flows from higher potential to lower potential. What does this mean? This is higher potential, this is lower potential. Correct? Higher to lower means potential drop is happening. Potential drop is happening means delta V will be negative, minus IR. Clear? Again, the direction of current I will take same only. This is I, this is R. Now my direction is in this direction. What will be delta V? What will be delta V? Current flows from higher to lower. Again, this will be positive, this will be negative. This time, my path is minus to plus. Here, my path was plus to minus, right? Here, my path, this red one, right? The loop what I have taken is in this direction. From minus to plus we are going. From lower to higher we are going. Potential gain is happening. This will be plus IR. Clear? Again, here also it follows the same thing. See, from positive to negative we are going. If you see this arrow, this is towards negative. Towards negative is minus IR. Here if you see, we are going towards positive. This was minus, this was plus. Towards positive means plus IR. Now how to remember this? One way to remember is seeing the signs. Towards which sign you are going, you can write that sign before, right? But seeing this sign is easy in battery, right? Here you can directly see, okay, this one is bigger, this is plus, this one is smaller, this is minus. In battery it is easy, but in resistors, how will you see? In resistors, what is easy to see? The direction of current, right? So remember or make a note. This is easy, I hope you get it, okay? In case of this resistors, make a note. If you are going in the same direction as current, delta V is negative. If you are going in opposite direction of current, delta V is positive. Loop is in or path. If path is in same direction of current, delta V is negative. All right, and the vice versa, and the opposite. If path is in opposite direction of current, delta V is positive. Clear? You'll remember this always. Okay. Once you will do certain questions, this will feed in your mind only. Don't worry. Okay. So till here, everything is done. We have understood both the laws. We have understood how to apply these laws. Now let's see the questions and apply the laws. Find current in each resistor. Okay, if this was not written using Kirchhoff's law, how you would have done it? You would have taken the equivalent resistance divided by this voltage. You would have got the current, right? See, R equivalent is equal to 2 plus 1 plus 2, that is equal to 5 ohm. Delta V is given to be 20 volt. Delta V is equal to IR, Ohm's law, right? From here, 20 is equal to 5 into I. From here, I is equal to 4 ampere, correct? If using Kirchhoff's law was not written, you would have done this way, 4 ampere. So that means the answer is the current is flowing like this as 4 ampere. This you know. Now why I have written using Kirchhoff's law? To prove that using Kirchhoff's law you will get the same answer. Okay? Because this is what you know. Using Kirchhoff's law also you will get the same answer. And when you use Kirchhoff's law, there is no need to use Ohm's law. Right? Now see. So first thing what we have to do is, this is just the previous methods what we did. Okay, easy questions, easy circuits, you have to do this way only. This takes time. This you have to only apply when there is a complex circuit. Okay, because in complex circuit it is difficult to find the equivalent resistance. Now see, the first thing how to apply, the first thing was we have to apply KCL. Applying KCL means we need to draw current from a cell and distribute it. So now from here, current will be in this direction. This is positive, this is negative, right? Here current will go like this. There is no junction, it is just a node, right? Current is not distributing. The same current is going here. The same current will go here, the same current will go here, the same current will go here. Clear? Now see, let's say this current is I. Now we have to assume a loop. You can assume any direction of loop, whether clockwise or anti-clockwise. First, let me do it taking clockwise, okay? I'll write I here. Now the direction of the loop, what I'm taking, I will choose some different color. Maybe this one. I am taking the direction like this, clockwise, okay? Now in this path only we'll move. And we'll keep on adding the potential difference with sign. Let's say using KVL or using Kirchhoff's law you can write. First we'll start from here. This 20, we'll write it as positive or negative. We are moving in this direction. The direction is like this. See, if you close the loop, the direction is like this, from negative to positive, or from lower potential to higher potential gain, or just see the sign, to positive. So it will be 20, right? Now from here if you see, our direction and current's direction is same. See, my direction in this loop is like this. Correct? Here for this resistor, our direction and current's direction is same. If the path's direction and the current direction is same, the potential difference is negative, right? So this will be minus, potential drop will be 2I, delta V is equal to IR. Current going is I in this resistor, resistance is 2. Or you can understand this way, see this is bigger one, right? So if this is positive, this will be positive, this will be negative, this will be positive, this will be negative, this will be positive, this will be negative. From here also you can see we are going to negative, that is why it is minus 2I. Here also it will be minus because we are going to minus, towards minus. Here also we are going towards minus. Okay? But still, just learn to see the direction of current. Now for this one, again our direction and current's direction is same. Current going inside this is also I, so potential drop will be minus I, minus 1I, that is minus I. Here again my direction and current's direction is same. Since it is same, it will be minus sign. Potential drop is 2I. And again we came back to the same point. We have already written this 20, no need to write this 20 again. We started from here, we came to the same point, the loop is complete. So the sum of potential differences in a loop should be 0. Now just see. 20 minus 2, 3, 4, 5. 5I is equal to 0. I is equal to, or 5I is equal to 20. I is equal to 4 ampere. Are we getting the same answer what we got by this particular method? See here. Right? That means Kirchhoff's law works. Kirchhoff's law works. Note it down. Easy? Okay. This was just a trial just to prove that this law works. Now we'll see a bit difficult questions. We'll keep increasing our level. Now here there are two batteries. How to do it? First thing, take out current from any one cell or more than one cell. What I recommend is always take out current from one cell only. Any one cell you can choose. Okay. So now let me take out current from here and use common sense also, use logics also. Okay. If you don't use, anyways, if the current comes as negative, that means the direction of current what you have assumed was wrong, right? You will get the correct answer at the end. But if you use logic initially only, common sense initially only, you will choose everything correctly. Okay. Now this is current. Why I am taking out current from here? Because this is the bigger battery, this is a smaller battery. Ultimately, in the entire circuit, the current will be like this only. You can draw from here also. You will get the current as negative. So that means the direction of current is like this. Okay, don't worry. Now, so this is one single circuit. See, batteries are two, but this circuit is only one, right? There is no other wire, there is no other junction. The current which is going, let's say I current is going, it is not distributing. The same I current is going here. The same I current is going here. The same I current is going here. The same I current is going here, right? And it is coming here. Now applying Kcl or applying Kirchhoff's law, you can say, because we are actually applying both. Now see. Now second thing is we have to assume the direction of loop. So which way you want to go? Let's this time go opposite to the direction of current. Last time we went in the direction of current. This time we'll go opposite to the direction of current. Alright. Let me make it properly. Now see, we'll start from where? Just make sure wherever you start from, you reach that point again. We'll start from this 20. Okay. Now here, this is positive, this is negative. Here, this is positive, this is negative. We are moving in this direction. So we are moving towards negative. If you see in this battery, right? So this will be minus 20. Okay. Then this one. Current is in this direction. We are moving in opposite direction. So since our direction is opposite to that of current, potential drop across the resistor will be positive. 2I. Then here we are going in this direction. And if you see this battery, we are going towards plus 4. Now here, our direction and current's direction is opposite. It will be plus 4I. Here, opposite, plus I. Coming here, again the direction of current and our path is opposite. So this will be plus 3I. And the sum, again we reached here, no need to write this again because we have already written this. The sum will be 0. Now see, minus 20 plus 4, minus 16, it will go that side, it will become 16. And here 2i plus 4i, 4, 5, 6, 7, 8, 9, 10. 10i is equal to 16, I is equal to 1.6 ampere. Since it is positive, that means the direction of current what we have assumed was correct. Note it down. Clear? All right. You can do it other ways also. See, we have seen combination of cells, if you remember, right? In combination of cells, now these two are actually connected in opposite polarity. This is also having plus here, this is also having plus here. So this will subtract this. They both will cancel each other, right? So the net potential difference will be 16. See, I'm going like this. This is from minus to plus. So here also minus to plus it should be, but it is from plus to minus. It will oppose this potential difference. Net potential difference, if I just make one battery and want to write potential difference, net potential difference will be 16 only, right? And the sum of all the resistance will be, since they all are in series, 3, 4, 3 plus 1, 4 plus 4, 8 plus 2, 10. 16 by 10, 1.6, right? So again, this was also easy. It was not necessary that you have to apply Kirchhoff's law to do it, but since we are doing Kirchhoff's law, we have done it in that way. Okay. Clear? Next. Acha, never forget to write the potential difference. Sometimes we'll only write resistance, because here we are writing 20, we are writing 4, only the numbers. Sometimes we only write resistance. Don't forget that. Always write potential difference. Keep in mind. Next, find current in each resistor. Now this question needs Kirchhoff's law. Without that, you cannot solve this. Okay, let's do it. Without that, it will be very difficult and time taking. First thing, now I hope you can do fast. Try doing it on your own. First thing, we have to draw current. I always recommend to draw current from only one source. Here, this is the biggest source, so I'll draw current from here. You can draw from any. At the end, you will get to know whether your direction was correct or not. I is coming out from here. Here also I is going. Now here, once I comes, now see Kcl Junction Rule. Now we came across a junction. So here it will be divided. You can divide it anyways. Let's say this is I1, this is I2. Alright. Again, here the current which will go is I1. Here it is going I2. Here I1, here I2. Both will join and finally again become I, and this I will go inside. Clear? Just see. I have drawn current I from here. This has gone to this junction, divided I1, I2. I1 is going in this, I1 is going in this, and I1 is coming from here. Here I2 is going, coming from here. I1, I2 again joined and came here and became I. Clear? I'll write it a bit far, otherwise you'll confused with I2. Now, second thing is choose a loop. So when there are many loops, you have to write the name of the loop. Okay. In the previous questions, we did not write the name of the loop. Here, how many loops can you select? Can you tell me? See, there are two unknowns, I1, I2. How many unknowns? I1, I2, right? So we have to select two loops to get the answer, because we need two different equations. If two unknowns are there, two simultaneous equations we solve, we get the two values, right? Don't say there are three unknowns, because this 3 is basically I1 plus I2 only. If we get I1, I2, I is I1 plus I2 only, right? There are two unknowns. We need to write two loops, equation from two loops. Now, how many loops can we select actually? You can select 3 loops, not only 2. One loop will be this complete loop, this one. One loop will be this loop. One loop will be this outer loop, complete loop. This is also a loop, right? So you can choose any two out of these 3. Okay. Either you can choose this and the bigger one, or this and the bigger one, or the two inner ones. Fine. Anything you can choose as a loop. It should be a closed loop. It should be you started from here, let's say. You started from here and you reached here back. That's all. This is a loop. You started from here and reached here back. This is a loop. You started from here and reached here again. This is a loop. All right. Fine. Now let us select a loop. Which loop? Let me select this one. Okay, let's select this as one loop. Okay, the direction I am choosing like this. Fine. This loop also I am choosing the direction like this. Clear? In both I have chosen clockwise. Now, which loop we are solving? We have to write the path for that. For that, let's name this. Let's say this is A, this is B, this is C, this is D, this is E, this is F. For loop A, B, E, F, or for path you can write. Usually people write path. Okay, let's solve this. Now we'll start from this battery. This is negative to positive we are going, right? This is negative, this is positive. Always mark in the battery. Now see, our direction, see our direction. Okay, always. Negative to positive, this will be 10. We'll do it fast. Here, current is in opposite direction to our direction, it will be negative. -4, the current going inside is I1. Then here again we are opposite to the direction of current. Since we are opposite, this will be plus. Sorry, this will be plus. We are opposite to the direction of current. Here also we are opposite to the direction of current. This will be plus 6I1. Then here, our direction, current direction is same, -5. Current going in this resistor is I2. And then this battery. From positive to negative, we are going towards negative, -20. Then here, we came back again to here. We have already written this. We are not going to write this again. This is one equation. If you want to simplify, you can simplify. This will be 6 plus 4 is 10I1 -5I2. 10 minus 20 is -10. If it will go to the other side, it will become 10. Simplifying this more, this will be 2I1. I am dividing the entire thing by 5. -I2 is equal to 2. This is first equation. See, if I divide the entire thing by 5, this will be 2I1 -I2 is equal to 2. Now, another loop. For loop, this one, B, C, D, E. Again, we can do it fast, right? This is, let's start from here. Our direction is this, -2 plus, towards plus. So this will be 20. Here, our direction and current's direction is opposite. So it will be plus 5I2. Here, again, our direction and current's direction is opposite. So this will be plus 6I. Then here, again, our direction and current's direction is opposite. So this will be plus 4I. Towards negative we are going, right? In this battery. That means -40. Again, coming from here, we came to the same battery, which we have already written, that is equal to 0. Two equations. This I, we can actually expand it. We can write I1 plus I2, correct? So this will be, now first 20 minus 40 is -20. If it will go to the other side, it will become plus 20. Now 6 plus 4, 10I plus 5I2 is equal to 20, correct? See? Now this I, This I will be I1 plus I2. So I can write this as 10 I1 plus 10 I2 plus 5 I2 is equal to 20. Correct? So this is 10 plus 5, 15 I2. So this will be 10 I1 plus 15 I2 is equal to 20. The same equation, 10 I1 plus 15 I2 is equal to 20. I can divide this also by 5, the entire equation. 2 I1 plus 3 I2 is equal to 4. This is my equation number 2. First equation is this one. Second equation is this one. We can solve these two equations, simultaneous equations. So let us solve this. So this is 2I1 minus I2 is equal to 2. 2I1 minus I2 is equal to 2. And this one is 2I1 plus 3I2 is equal to 4. Correct? So this will be, if I subtract, these and these will be cancelled. Minus I2 minus 3I2 is minus 4I2. Here this will be 2 minus 4 is minus 2. Correct? 2 minus 4 is minus 2. Minus I2 minus 3I2 minus 4I2. 2 minus 4 is minus 2. So from here I2 will be equal to 2 by 4. That is 1 by 2. So I2 is basically 0.5 ampere. Here also I can write ampere. Clear? Now see, since this is positive, that means the direction what I assumed was correct. I2 I have got. Now can I get I1? Yes. From here only, 2I1 plus 3I2, or let's write the first equation, 2I1 minus I2 is equal to 2. 2I1 from equation 1, 2I1 minus I2 is equal to 2. So this is 2I1 minus 0.5 is equal to 2. That is 2I1 is equal to 2.5. That is I1 is equal to 1.25 ampere. Clear? I hope this calculation is correct. Just check. See, don't worry about the calculation, whether it is correct or not. Because these are equations, some mistake can happen. Right? We are not solving maths here. We are doing physics here. The main thing is to understand the concept. Alright? Okay. Just note it down. Done. Now what will be I? I1 plus I2. That is equal to 1.25 plus 0.5, that is 1.75 ampere. That is I. So now in this circuit, 1.75 ampere current is going from here. Here it is going 1.25 and here it is going 0.5. Clear? The entire data of the circuit we have got. That's what we have to find. Find current in each resistor. Each resistor means this resistor how much current? 1.75. This resistor how much current? 1.75. This resistor how much current? 1.25. This resistor 1.25. This resistor 0.5. I hope you can write this. All right. Next, let us move to one of the most difficult, not most difficult. In the set of questions what I've brought, this is the last question where it will be having more difficulty, okay? Find current in each resistor. Try doing it on your own. Now from here, what we'll do, we'll draw current from this particular battery, okay? Now, from here if I draw current, the first thing is drawing current. We'll be doing fast, okay? Now this is I, right? The bigger battery is this. I will be drawn from here. Now from here, I is there. It will be distributed. This will be I1. This will be I2. Correct? Now see, always, whenever you are distributing current, make sure you are using least variables which are unknown. Least number of variables which are unknown. Because here, now see, this I2 will be going here. This I2 which is going here will divide here, correct? Now you can again give this number as I3, I4. But instead of giving it I4, what you can do is, now see, from here this is I1, I1, I1. I1 is coming from here, okay? I1 is coming from here. Now here this is I2. So this, let's say this is I3. No other option. We have to give a different variable. If this is I3, this will be I3 minus I2. Correct? Sorry, I2 minus I3. I2 minus I3. Right? Just see this. I2 was this, I3 went here, I2 minus I3. Instead of I4, we are giving this. Alright. Now see, this from here, again I1 is only going, no, I1 plus I3 is going here. I3 is coming from here, I1 is coming from here, here, I1 plus I3. Alright. Clear? So I1 plus I3 is going here. From here, see how much we got here. I1 plus I3, I1 plus I3 plus I2 minus I3. I1 plus I2. It is I only. I was distributed as I1 plus I2, right? So at the end, anyways, whatever current was drawn from the battery, the same current has to enter the battery. So I was drawn, I will enter. Clear? So this will be the distribution of current. You can do it from this battery also. Not a problem. Okay. Now, second thing is loop. How many unknowns? I1, I2, I3. 3 unknowns, 3 loops, right? So we can take 3 small loops, these 3. So one loop I will be taking this one. Second loop I will be taking this one. Third loop I will be taking this one. Clear? And then we'll be solving it. Fine. Let us name also. It will be easy. A, B, C, D, E, F, and G. This is one more junction, right? Now, from or for loop, first we'll select any loop we can select. Let's select this one. B, C or C, B, E, D. C, B, E, D. Achha, while writing the name of the loop, write it in the direction which you have assumed. This direction is anti-clockwise. So this only you will take C, B, E, D. Clear? For loop C, B, E, D. Now see. Now see. 15. From negative to positive we are going. Our direction is this. So this will be 15. We'll do it fast. The direction of current and my direction is same here. Here also it is same. So here, since it is same, it will be minus 3I2. See, the current going in this is I2. Then again coming down, in the same line I am coming down, this is 3. The current is I2 minus I3. Direction is same, so minus 3I2 minus I3. Then this will be closed and that is equal to 0. Now here I can write as, see, 15 minus 3I2 minus 3I2 minus 3 plus 3I3 is equal to 0. This will be 15 minus 6i2 plus 3i3 is equal to 0. I can divide this entire thing by 3. 5 minus 2i2 plus i3 is equal to 0. See? So now this will be 2i2 minus i3 is equal to 5. This is one equation. 2i2 minus i3 is equal to 5. All right. Now next, let us take this loop. This is A, B, G. Okay, one more point is there, H. A, B, G, H, right? For loop A, B, G, H. Let us start from here. 9 volt. See, our direction is in this direction. Here this is negative to positive, right? So this will be 9 only, 9. Then our direction is opposite to that of current, right? See? So if this is opposite to that of current, it will be plus 6 and current is I1. Then again going here, it is in the same direction as that of current. So it will be minus 3 I2. Then here, same direction of current, that is 3, same direction means minus 3. Minus 3 I3. Correct? This is I3. Then we came to the same battery. So this is equal to 0. In a loop, it is 0, right? So now this is, all right. Again, I can divide this entire equation by 3. So this will be 3 plus 2i1 minus i2 minus i3 is equal to 0. 3 plus 2i1 minus i2 minus i3 is equal to 0. From here, this is minus 2i1 plus i2 minus 2i1 plus i2 plus i3 is equal to 3, correct? This went that side, this went that side, this went that side is equal to 3. This is my equation number 2. Third equation will be from this loop. Now see, this is this direction I have taken, right? This direction means I can write as HFEG or GHFE. G, okay. For loop GHFE. GHFE. All right. For this loop, again, this is negative to positive. It will be 9. Then from here, in the same direction of current, that is minus sign, minus 6. Current is I1 plus I3. Then this is opposite to that of current. So 3, opposite means plus, right? So this will be plus 3, current is I2 minus I3. See, I2 minus I3. Then here, we are in the same direction of current, minus 3 I3. Minus 3 I3. Minus 3 I3, again we reach to the battery, so this will be equal to 0. Now see, this if I expand it, 9 minus 6 I1 minus 6 I3 plus 3 I2 minus 3 I3 minus 3 I3 is equal to 0. 6 I1 only 1, I2 only 1, I3 there are 3 terms. Minus 6 I3, minus 3 I3, minus 3 I3, 6, 7, 8, 9, 10, 11, 12, minus 12. So this will be 9 minus 6 I1 minus 3 I2 minus 12 I3 is equal to 0. Correct? So this will be, if I divide this entire, I can divide this entire thing by 3. So from here, let me just write 9 minus 6 I1 minus 3 I2 Is it minus? This is plus 3i2. See, a mistake could have happened. Plus 3i2. Plus 3i2 minus 12i3 is equal to 0. Dividing entire thing by 3, 3 minus 2i1 plus i2 minus 4i3 is equal to 0. From here, I can write minus 2i1 plus i2 minus 4i3 is equal to 3. Wait. Two minus this plus this. 2i1 minus i2 plus 4i3. 2i1 minus i2 plus 4. All of them went there. 3 remained this side. This is our equation number 3. 3 equations you have got. 3 unknowns are there. Can you solve and find it? See, equation number 3 if you see, equation number 2 if you see, and equation number 3 if you see. 2i1 minus i2. This is minus 2i1 plus i2. If I add these two equations, let's see. Adding equations 2 and 3. So that is minus 2i1 plus i2 plus i3 is equal to 3. This is 2i1 minus i2 plus 4i3 is equal to 3. Adding both, I am going to get these two will be subtracted. 4i3 plus i3, 5i3 is equal to 6. From here, i3 is equal to 6 by 5, that is 1.2 ampere. Clear? 1.2 ampere. Now I2 from here, equation 1. I3 we know, I2 we can get 2i2 minus I3 is equal to 5, right? From equation 1. From equation 1. 2i2 minus I3 is equal to 5. 2i2 minus I3 is equal to 5. I3 is given as 1.2. So 5 plus 1.2, 6.2. 6.2, I2 will be 6.2 divided by 2, that is 3.1 ampere. And how much will be I1? We'll put in any equation. Let's say we'll put in this one. 2i1 from equation 2. 2i1 minus 3.1 plus 4 times 1.2, that is equal to 3. So now see, 4 into 1.2 is 4.8. 4.8 minus 3.1 is 1.7. 1.7, if it goes to the other side and subtracted from 3, it will be 1.3. Correct. So I1 will be 1.3 I1. 1.3 divided by 2, that is 0.65 ampere. All the three currents you have got, I1, I2, I3. I will be equal to I1 plus I2 plus I3? No, always remember, you took I, you distributed I as I1 and I2. So I is I1 plus I2. I1 plus I2, that is I is equal to I1 plus I2, that is 0.65 plus 3.1, that is 3.75 ampere. Clear? Now you got the current. In the circuit, however you have divided the current, give the current that way. Here, I1, 0.65 ampere will go here. here, I2 3.1 ampere will go here in this resistor. In this resistor 1.2 ampere will go, right? And in this resistor I1 plus I3. I1 plus I3 means I1 plus I3. Just a second. I1 is 0.65. I3 is 1.2. Just add that current is going here. Clear? All right. Now, let's go to the next question. Again, very easy. We'll do it fast. See here. Now, we know that Kirchhoff's law can be applied in a loop, right? Can you see a loop here? This is a straight line. I wanted to tell you how to do these questions. That's why I have put these questions here. There is a straight line. Vp minus Vq I have to find out. So what I can do is, I can assume a loop. Let me assume a loop. Since I have to find Vp minus Vq, the line which was near P, that potential I have kept as positive and this potential I have kept as negative. So this will be P, this will be Q. So seeing here, this is basically Vp minus Vq, correct? The potential difference in this battery where one terminal is at P, other terminal is at Q, the potential difference across the battery is Vp minus Vq only. Correct? You can understand this way. Oh, this P is this plus, Q is minus. So this is plus Vp, this is minus Vq. See, understand, in any battery, if the potential difference is V, what we take? We take this as V and this as 0, correct? Why? This is as positive, this is that negative. So plus V minus 0, what comes? V only comes. That's what I've done. Clear? So now from here, now can I write for the loop? See, the loop is completed. Now if I take one loop, just like this. I'm taking a loop like this, okay? Now for this loop, let me just write applying KCL. Now see, this is Vp minus Vq. From here, Vp, or you can just go Vp and then come here and write minus Vq. That also you can do, okay? I'm writing Vp minus Vq. Then here my direction and current is given as 3 ampere. My direction, current direction is same. So this will be minus 2 into 3. 2 into 3, right? Then here 4 plus 4, because this is minus, this is plus. Then here my direction, current's direction is same. Since it is same, it will be minus 3. It is one single wire. The current will be same, that is 3. From here, plus 6 is equal to 0. See, again we came to the same battery. Now that is Vp minus Vq minus 6 plus 4 minus 9 plus 6 is equal to 0. So Vp minus Vq, minus 6 plus 4 is minus 2. 3 3s are 9. Minus 2, minus 6 plus 4, minus 2, minus 11, plus 6, 5. See, if I am not wrong, 9, 6, 15, 6, 4, 10. This is 5 volt. Just check it, right? We'll go fast because we have already extended the session. Next, Vx minus Vy. Again, let us complete this circuit. Completing this circuit, since I have to find Vx minus Vy, I am taking this side as bigger because X is this side. This will be X, this will be Y. This is at bigger potential, this is at lower potential. Applying KVL, Vx minus Vy, and here, okay, we have to choose the loop also. I am taking the loop again like this only. Just I wanted to tell you the way how to do it. Just assume it as a closed loop. You'll get Vx minus Vy only. Okay. So from here, Vx minus Vy, then Direction of mine and current is same, 2 into 2. Since it is same, it will be minus 4. Here, now here the batteries are different, opposite. We are going towards negative, so minus 4. Then here, 3 2s are 6, same direction, minus sign. Plus 6 is equal to 0. So from here, Vx minus Vy is equal to, these and these will be cancelled. This will be 4 for 8, going other side 8 volt. Clear? I hope you got it. Voltage can come as negative also. Potential difference can come as negative also. That means potential drop is happening as you are going from here to here, from X to Y. Don't worry. If in any question your potential is coming as negative, that means potential drop happened as you move from here to here. Okay? Here, since it is coming as positive, that means potential gain happened as we are moving from here to here. Clear? I hope you understood today's session. In the next session, we'll be doing meter bridge and potentiometer. In today's session, we have covered all kind of questions on Kirchhoff's law, all different kind of possible questions. Practice these questions on your own. You will understand the law better. All right. I hope you liked today's session. If you liked it, do press the like button. Share it with your other friends who are preparing for their boards and competition as well. Subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. All right. We'll meet up in the next session. Till then, keep learning from We Learning. All the best.